Geometric series, nth term test for divergence and telescoping series. Geometric series test. A geometric series is in the form of n equals 0 to infinity of a sub 1 r to the n, or n equals 1 to infinity a sub 1 r to the n minus 1, where a does not equal 0. The geometric series diverges if the absolute value of r is greater than or equal to 1. If r, our common ratio, is less than 1, the series converges to the following sum: s equals a sub 1 over 1 minus r. And yes, this is supposed to be the absolute value of r. Okay, determine whether the following series converges or diverges. Okay, so what are we going to do? I think we need to figure out what r is. So, maybe we should write out what this is. This is 3 over 2. This is 3 over 2 squared. This is 3 over 2 cubed. So what's r? R equals a half. Because I said 1/2 times this made this, then 1/2 times this would make the next one. Okay, so therefore what? Right, r is less than 1, so converges. Yeah, yeah. And what would s be? S would be equal to a1, which is 3/2, divided by 1 minus r, which was 1/2. So I would have 3/2 divided by 1/2. So I would have 3. Okay, now, this one is a little different. What's r? Right, r is 3/2 here. Because I would have 3/2 to the first, plus 3/2 to the second, plus 3/2 cubed, etc., right? So r is 3/2. So r is greater than 1. So diverges. That one's pretty easy, right? Okay, now, nth term test for divergence. Notice it doesn't say for convergence. Notice it says divergence. Okay, if the limit as n goes to infinity of a sub n does not equal 0, then the series n equals 1 to infinity a sub n diverges. This is very important right here. This does not say that if it equals 0, this does not say that if the limit as n goes to infinity of a sub n equals 0, then the series converges. This test can only be used to prove divergence. If n goes to infinity of a sub n equals 0, then this test doesn't tell us anything. And we need to use another test. Guess what? There's 9 tests, so, it's up for grabs here. Yep. Because they do not let you have a little cheat sheet or anything. So among the thousands of other things you're memorizing, you got to memorize the test too. Okay.
Are these the 9 rules that you told us that you don't have memorized?
Right.
So she doesn't have to memorize.
You have to. I memorized them when I took the AP test, but I don't know them anymore. I mean, I didn't know them at one time, but now every time I look at them, hey, you're not writing them on your hand or your arm. Good for you. Cheater readers, you're not allowed to do that.
Each one of us is gonna have a different one on the back of their shirts. Like, that'll be our names.
Are we having an AP shirt, by the way?
We should.
Yeah.
Is somebody going to start working on that anytime soon?
Brendan, I'll do it. I won't design it, but I'll take care of it.
Well, somebody has to design.
I say we do a really long math problems and at the bottom just put false, because that's what my calculator did to me one time.
Oh,
I clicked it, it like worked for 5 minutes and it just said false. I was really sad.
Miss Amor, I think I'm gonna start calling you Miss Hattie.
It is not. It's just like
Why?
Should I ask why?
false.
Because you're
It
evil.
was like false.
Okay. I gather this lady's evil. Where is she from?
She's from Despicable Me. Oh my gosh.
Oh, that is
That Miss
Hattie.
Hattie.
Oh, see, she's not that bad. Okay, now.
She
All right.
makes little girls selling cookies.
Well,
Keeps
that,
them ready.
yeah. I couldn't believe she was mean.
You make little girls do.
And she wasn't in those boxes. The box of shame?
Yeah.
Yeah. It's like the Bible.
That's very bad. Limit as n goes to
Yeah, I
infinity of 2 to the n plus 3 over 3 to the n minus 5 equals 2/3. 2/3 does not equal 0, therefore diverge. Right? Okay. Limit as n goes to infinity of n factorial over 2n factorial plus 1. Now, if you don't know this technique, you can divide everybody by the highest factorial. So, let's do limit as n goes to infinity. It's just like dividing everybody in here by an n. So we're going to say n factorial over n factorial divided by 2n factorial over n factorial plus 1 over n factorial equals the limit as n goes to infinity of 1 divided by 2 plus 1 over n factorial. So what do we get? 1/2. So 1/2 does not equal 0, therefore diverge. How did I get what?
Just get 1/2 in the beginning because they have the same.
Yes, but a lot of people don't like to say they have the same degree because it's weird.
So when
I mean, but when they multiply it out, it'd be like n cubed over n cubed. I mean,
so if we just went straight to 1/2.
yeah, that'll be fine.
That's okay. Do you have to show all this stuff? You say degrees.
Do not say degree.
Okay. Just kidding.
Just write limit equals 1/2, but do not say degree. Because you would have to explain that. You'd have to explain when I multiplied it out, these two would have the same degree, da 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 da. How about this? You.
Yes. Isn't this just
Okay, why?
because they have separated into fractions.
The not degrees are the same.
Right, the not degrees are the same, exactly. I would divide everybody by 3 to the n. Really, if I had to show this, I would say n goes to infinity, and I would say 3 to the n divided by 3 to the n minus 2 over 3 to the n, all over 3 to the n divided by 3 to the n, which would be 1. And that would be, because it would be 1 minus 2 over 3 to the n, all divided by 1. Limit as n goes to infinity. So this would be 1. 1 does not equal 0, so diverge.
You just separated it.
Yep.
3 halves over 3 halves.
As long as you separate both of them, you're good. And you talk about both pieces, you're good. All right, now, this one is what we call a telescoping series. A series such as 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus is called a telescoping series because it collapses to one term or to a very few terms. If a series collapses to a finite sum, then it converges by the telescoping series test.
Is this one of the 9?
Yeah,
I just want to make sure it's like this is part of the 9.
okay. Now, all right. We have, if we put 1 in here, what do we get? 1/3 minus 1/5 plus, you have to show what kind of series this is, folks. If I put 2 in here, I get 1/5 minus 1/7 plus, if I put the next one in, 3, I get 1/7 plus minus 1/9 plus ... Okay, now, what's going to happen? This is collapsing, so I'll wind up with converge, and it just happens to be what? 1/3, because all the others cancel each other out. Okay? Because that's what it collapses to.
On that one, it's not like it's like the other test where it's like something you have to do to you just write this out.
Right, you have to write it out and show that it actually is a telescoping series.
So how does this, what is the application of this?
Taylor series and McLaren series, they're coming. Let's not jump to that yet. Let's just get these down, take care of it, move on. Okay, because I want to try to get as much done as I can before the break. Okay. This way, some of the band kids can take this stuff on their charming little trip.
Yay!
And be confused, it won't be here. Okay.
So is there like derivatives and second derivatives that you can do like distance, speed, and acceleration? Is there something like that with this?
Not really. This is just flat out. Okay.
It's like a TV show.
All right. The integral test. All right.
Yeah, what's that?
What is it? Is it a coffee?
You just said it was so funny.
That doesn't mean, I mean, I've seen movies that were not billed as comedies, and they were
People
not.
have a different thing.
Okay? Some of us think things are funny that really
My
aren't
friends
funny.
love
Okay.
jumping down the stairs, and so do I. Other people don't.
It's falling apart.
Integral test and P series. The integral test. If f, my function, is positive, continuous, and decreasing for x is greater than or equal to 1, and a sub n equals f of x, then if I do the sum of n equals 1 to infinity of a sub n and 1 to infinity of f of x dx, either both converge or both diverge. Okay? If the series converges to S, then the remainder, R sub n equals S minus S sub n, is bounded by the following. 0 is less than or equal to R sub n, which is less than or equal to n to infinity of f of x dx. Now, this is a whole bunch of words. What do they mean? This is what we're going to find out. First things first. We have to figure out if this integral diverges or converges. Okay? Before we can even do anything else. Alright, so we're not doing any error on this one. We're just figuring out if it converges or diverges. First of all, is this positive, continuous, and decreasing? Well, let's see. 1 over 2. 2 over 5.
Yes.
3 over 10. Sounds to me like it's positive and it's decreasing, right? Right. So that's good. We're good to go. We checked this. It works. It was positive, continuous, and decreasing. Okie dokie. So let's do the integral. Let's integrate from 1 to infinity of my function, which is a sub n over n squared plus 1, dn. Or you could write, let's just write it with x's, 1 to infinity of x over x squared plus 1 dx. All right, now, remember this infinity thing we did? So don't we have to do the limit right as x goes to c of the integral of, or wait a second, c goes to infinity, doesn't it? And we go 1 to c of x over x squared plus 1 dx. Yeah, you do. You have to show them that you're doing that. Yeah. What now? That doesn't, no, that's fine. No, because it's not. It doesn't. By the way, this is going to diverge. Okay? So, let's, because I'm integrating it in my head. Okay, now, wait a second. That thing right there, that's a sum, okay? Now, this thing right here is a sum. Now, we have, Ethan, if you start putting the numbers in there, you have a half, then you have 2/5, then you have 3/10, then you have 4/17, is it? And you've got to figure out if that's converging or diverging. Okay, now, it's not geometric. Okay? I don't think it's any of those other tests we just did. Because if I look at this, all right, all right, look at this. This thing right here. If you do this, and you do the limit as n goes to infinity, guys, if you do n goes to infinity, this is 0. 0 doesn't tell you whether you diverge or converge. Remember, this said it can't be 0. If the limit is equal to 0, that doesn't tell you anything. You have to use a different test. What now? Okay, one more time. I'm going to say it from the top. I did this. If I do his limit as n goes to infinity, I get 0. This thing right here said, if this limit equals 0, then this test does not tell us anything. And we must use a different test. Okay, so I can't use the first one. It's not geometric. I can't use the second one because the limit goes to 0 and that doesn't tell me anything. It's not telescoping. So, now I'm on this test. Right, thank you. Okay, now, guys, really, like Ethan was doing, he's trying to go through the test. If it had met any of those other tests, you'd be good. But it doesn't. I mean, it didn't do geometric. Then it didn't do the second one we know how to do, which was, seeing if it diverged because the limit going to infinity. And then it didn't do the third thing, telescoping. So you got to come up with another one. There's 9 tests altogether. So this is the 4th one. Okay, so we can do this test to see if you diverge or converge. How do I integrate this?
You can use substitution.
U equals x squared plus 1. Du equals 2x dx. 1/2 du equals x dx. So now I'm still going to have the limit thing, right? But I'm going to go from 1 to some c of, what do we have here? Don't we have to change those? If we don't want to go back, we have to change them. So I'm not even going to put this on here. I'm just going to integrate. I'm going to say I have 1/2 du over u. So I have 1/2 the integral of du over u. So what is that? 1/2 natural log of u, which is equal to 1/2 the natural log of x squared plus 1. So now I have to do the limit as c goes to infinity of 1/2 of ln of c squared plus 1 minus 1/2 ln of 1 squared plus 1. Right? Because didn't I have to go back and put in the 1 and the c into this integral? So I get this. So what does that go toward? This goes toward infinity. So it said up here what? I'm thinking if I go toward an infinitely big number, what is that going to mean? Diverge. What now? What are they talking about?
We think your dots in the wrong place.
You want to dot the I.
Oh, I just done anywhere. There. It's dotted. Okay, now. It's above it, isn't it? What else do you want? Okay, yeah.
It's called the tittle.
All right.
Okay, so
What now?
what's all the stuff with like RN and S and zeros?
We're not to any of that. This is just the first part. Either we converge or we diverge. Okay. The only way, first of all, the only way that you can have any remainder, like there's an error in your convergence, you know, there's a little bit of error to either side, is if the series converge. Because if it diverges, it's just getting bigger and bigger and bigger, right? So this one, we don't have to do any of that R sub n stuff. Okay?
Oh, if the series.
Yeah. And it's only if they ask. Malia, you don't want to do this if they don't ask. Okay.
So if they don't ask, they should ask the first part.
Yeah, see, you see, like number 2, down at the bottom there? It says approximate the sum of the convergent series by using 6 terms. Include an estimate of the maximum error for your approximation. Yeah, that's where they want us to do this other stuff they're talking about up there. Which I'm going to show you how to do, okay? Just give me a chance. Okie dokie. Now, let's try this one. This is 1/2 plus 1/5 plus 1/10. Does everybody see that that's going down?
Yeah.
Okay, it is positive. It is like on that last page we just had. We could try to see if it's geometric. It's not. Okay, then we could see nth term for divergence. Okay, it says if the limit as n goes to infinity, what's the limit of this thing? Okay, so that tells us nothing, right? And we're also not a telescoping series. So here we go again. Let's use the integral test. Okay. So, integrating limit as c goes to infinity of the integral of 1 to c of 1 over x squared plus 1 dx. And all of you know this one by heart, yes? Arctan, yes? Arctan, and we're going to go from 1 to c, and we're going to do a limit on this, right? So we have the limit as c goes to infinity of arctan of c minus arctan of 1. Okay. What makes tangent go to infinity? Pi over 2. What makes tangent go to 1? Pi over 4. So, this goes to a specific number, pi over 4. So that means this converges. That's all they want to know. Converge or diverge.
Does it matter?
You're going to use this when you do series. More series. Bigger series.
They're not ever connected. Because you can't see which number converges.
Right.
It's just that it converges.
Whether it does or doesn't. Right. Okay. Whether it's growing closer to something or it's growing forever. Okay, now, approximate the sum of the convergent series n equals 1 to infinity of 1 over n to the 4th by using 6 terms. Okay, I could do it. I could do it. S sub 6 equals, I'm going to add these terms up. I'm going to have 1 over 1 to the 4th plus 1 over 2 to the 4th plus 1 over 3 to the 4th plus 1 over 4 to the 4th plus 1 over 5 to the 4th plus 1 over 6 to the 4th. Somebody tell me, what is that? And I want decimals. Big ones.
So this is just use our calculator.
Yes.
Oh, so these tests, if we don't fail. If we do them.
If they ask you for this, not all the tests, no. If they ask for this specific thing, yes, you would have to have a calculator.
So are these definitely going to be on the test?
Oh, yeah. No doubt in my mind. There's a free response every year on series and sequences.
I remember response question.
1.08.
6, 1.08, 1, 1, 2, 3, 5, 3, 3, 9, 5, 0, 6. That's what I'm talking about there. Mega decimals. 1.08 and a lot more. Now, do you see at this very top here it says n to infinity?
Yeah.
I'm very excited about that.
Dude.
Guys, do you see this at the very top of the note where it says it's talking about this estimate of the remainder, okay? And it's bounded here. All right, so it says n to infinity. So that's what I want to do. I want to integrate from r sub 6 equals 6 to infinity of 1 over x to the 4th dx. This is a 6.
Oh, look at you.
Better? Okay, so that means I have to say limit as x goes to c of the integral of 6 to c of x to the negative 4 dx.
The limit of c goes to infinity.
Oh yeah. I do that every time and I don't know why.
Is the average x to c?
Limit as c goes to infinity of 6 goes to c of x to the negative 4 dx. Okay.
You realize that you're saying like halfway to that line.
All right.
X.
Guys, let's move on. This is what? Negative 1 over 3x cubed from 6 to c. So now I have a limit as x goes to infinity of negative 1 over 3c cubed minus negative 1 over 3 times 6 cubed. What is this? What?
C goes
What is this number? I need a decimal. Give me a decimal.
to 0.01543.
Okay, so this is the deal. This is how you do this. I want you to put an S down. I want you to put S down. That's your sum. Now, I want you to take this number right here, the big one, and add this to it, and somebody else take this big number and subtract this.
Oh, is that the remainder thing?
Okay, I got subtract.
Okay?
1.0796. Or do you want the bigger one?
Okay?
The big one's 1.826. 1.082666.
Okay. Our real sum of all of these things is somewhere in between there.
That's not a very broad range.
Exactly. We want this to be small. You're saying that the error is really small. You're really close. Just keep making fun of me. I
So
get
now
out
you
the
put
grade.
it on just cute.
Just keep it up. Keep it up!
You look very pretty. Very pretty.
Hey, will you stay right
Okay. Now, we need to do.
Miss Emerald, we'll just buy you a bunch of bananas to eat over the pain.
Okay, I lost my last page of notes here.
Stop.
Okay, so you got that phone number for this info, but up here it says 0.
But
That's all you need to say.
okay, that's R, but we're using R. We're using R to figure out where our sum is. They talk about this, but really what we want to know is where that's trying to help you get R sub n. Like you use that now, and then you can take your sum, because R sub n is equal to S minus S sub n.
They're still learning.
And if we put that in there, okay, if you were to put this in there, look at this. Okay, you see this right here? Okay, so I would have 0 is less than or equal to S minus S sub n is less than or equal to this. Now, if we solve for S in the middle here, we would get S sub n is less than or equal to S which is less than or equal to this thing plus S sub n. Okay? And that's what this is right here. When you do this. That's what that is, Lauren, okay? You see what she's asking? And that's what happened. Okay? Alright, now, last thing was P series.
This is statistics related.
I don't know. It might be harmonic. Yeah, it probably is. A series, okay, the next one. A series of the form n equals 1 to infinity of 1 over n to the p equals 1 over 1 to the p plus 1 over 2 to the p plus 1 over 3 to the p plus 1 over n to the p is called a p series where p is a positive constant. For p equals 1, the series n equals 1 to infinity of 1 over n equals 1 plus 1/2 plus 1/3 plus 1 over n, etc., etc., etc. And this is called a harmonic series. Okay, now, we need to find out whether we diverge or converge with this. All right, if p is equal to 1, what's going to happen? Well, I have, what do we end up with? 1 plus 1/2 plus 1/3, right? Etc. Now, if I do, okay, I have to go through that whole routine again. I go to the first time. Do I have an R? Geometric series? No, I do not. If I take the limit as n goes to infinity, what do I get? 0. So I can't use that test for divergence. Next one, is it telescoping? No. So let's try the only other one we've got in our arsenal right now, the integral test. Okay, so let's integrate this dude. So we have limit as c goes to infinity of 1 to infinity of 1 over n, right? Or 1 over x dx. Because if I put 1 in, I get 1. If I put 2 in, I get 1/2. If I put 3 in, I get 1/3. Okay, so what do we get? The limit as c goes to infinity of ln of c minus ln of 1. So this is infinity and this diverges. Okay, so down here I'm going to say if p equals 1, diverge. This is my little, like all the way down at the bottom there, I'm putting p equals 1, diverge. Okay, now, how about if I have 1.1? Well, I would have 1 over 1 to the 1.1 plus 1 over 2 to the 1.1 plus 1 over 3 to the 1.1, etc. Right? Okay, now, if you go through all the stuff, you find out once again, you only have the integral test to use. All right, so if I integrate this, I get the limit as c goes to infinity of 1 to c of 1 over x to the 1 point.
It's just x in the negative 1.
Yeah. Okay, dx. And so this is the limit as c goes to infinity of what? If you integrate from 1 to c of x to the negative 1.1 dx, what do you get? Limit as c goes to infinity of x to the negative 0.1 over negative 1/10, and I go from 1 to c. I go from 1 to c. Now, what does that mean? Okay, it means I have the limit as c goes to infinity of negative 10 over c to the 1/10 minus negative 10 over c to the, over 1 to the 1/10. And this is equal to, if this goes to infinity, what happens to this? So I end up with 10, and this converges. So that means that if p is greater than 1, we converge. Okay, now, what you're going to do tonight is you have to finish that last one, and if you want to start working on this, you can. But I don't think you can because we don't know the last thing about the p-series. Here, some of you might want to take this. I don't care. Here, take it.
Actually, can you send it to yeah.
Some people might want to start working on it.
So, the same on the P-series? No, no. We just need to know if it gets stuck.
I passed for down this road because I think you have one? Lauren, do you have one?
Yes.
There should be another one. Somebody has two.
So, Lauren, you said